Welcome to the Bible and Science. This is Dave Prentice. I'm a retired public high school teacher, certified in all branches of science and math. I've also taught on the Bible and Science for many years, both in the U.S. and on many overseas mission trips. This is episode 42 of the Bible and Science. In the previous episode, we dealt with the question of would amphibians have gradually evolved into reptiles? And I think the answer is pretty obviously no. There are too many differences between them for this to happen just by some sort of random chance process. Now, God could have done it if he wanted to, but he put mechanisms into the cells to prevent major changes. So let's talk now about what do we really know about the dinosaurs. What were they? Well, we know from their jaw structure that they were reptiles, class Reptilia. Within the reptiles, there were several different orders, but the one that has to do with dinosaurs, the two that have to do with dinosaurs, are Saurischia and Ornithischia. Saurischia had a pelvis that was very much like what we consider lizards to have, and Ornithischia had a pelvis that was very much like what we consider birds to have. So we know there were reptiles because of the jaw structure. Depending on who is doing the classifying, Reptilia included at least 7 subclasses. Subclass Archosauria, which is what we're dealing with the dinosaurs, it included 5 orders. 1 was crocodile-type animals. 2 were flying reptiles. 3 were thecodonts, which are believed to be the ancestors of the other 4 because there's nothing else to offer in its place. I would reject that. I don't think anything evolved. But then there were also 2 orders of dinosaurs. The Saurischia was dinosaurs with a lizard-type pelvis that radiated in 3 different directions. And you can see a diagram at the center left of the screen. But those have the wrong type of pelvis to be the ancestors of birds. Nevertheless, they're considered by those who believe in evolution to be the ancestors of birds. The other order was Ornithischia. If you recognize that syllable phrase, Ornithischia, whatever, it had to do with birds. So dinosaurs with a bird-type pelvis had it radiating in 4 different directions. They're not considered ancestors of birds. The bird-type pelvis is supposed to have evolved 2 separate times because of mutations in the DNA of some ancestral reptile, whatever it was. So you can put together a cladogram which assumes that every living thing evolved from common ancestors. So there's a cladogram shown on the screen. The relationship are presented in such a way as this for the reptiles associated with dinosaurs. You had the Ornithodira, the Dinosauromorpha, the Dinosauria, the Saurischia, the Sauropodomorpha. So the Ornithodirans are assumed to have evolved into both pterosaurs and dinosauromorphs. The latter, the dinosauromorphs, are assumed to have evolved into marsupials and dinosaurians, and then the latter, the dinosaurs, are assumed to evolve into ornithischians and saurischians and similar forms. Okay, what are the transitional forms that enable us to put together this cladogram? There are none. Cladograms don't require any fossil samples in order to be assembled. They're based on the assumption that evolution took place. So most people have got this idea that all dinosaurs were enormous. A lot of the dinosaurs were very large. A few of them grew to enormous size, like the Argentinosaurus, the sauropod and so forth. Very large. Others never grew bigger than a chicken. At least we've never found any individuals that show that they were of a size larger than a chicken. That would be a picture right in the center, smallest dinosaurs compared to humans. They were pretty small, like maybe the size of a poodle or something smaller than that. But even the large dinosaurs had small eggs. If you look on the left side, that's a Tyrannosaurus rex egg, which was about the size of a football. And then on the right, a Spirolithius, a duck-billed dinosaur. Its eggs were approximately melon-sized. So if we consider the things that are going to expect in the fossil record based on whether you believe in creation or evolution, creation is initial complexity. Things started complex and have deteriorated. So according to initial complexity, creation, the rock strata, the fossils we find in there, represent ecological communities. There should be a pattern of clearly defined fossil communities around the world. Characteristic suites of fossils are precisely how we identify each stratum. So what we observe in the rocks is exactly what initial complexity led us to expect. Now on the other side, if you believe in evolution, simple to complex, initial disorganization, then you would say that the rock layers, the strata, represent time periods. There should be a continual overlap of life forms with no consistent worldwide patterns. So some ancestral type creature, Luca, last universal common ancestor, began to evolve this way in one area and a different way in a different area and a different way in a different area at different times. So there should be a continual overlap of life forms. There shouldn't be any consistent worldwide patterns. But that is precisely how we identify rock layers. This requires a great deal of explanation or explaining away in order to fit with initial disorganization, evolution. So this is something I've referred to before because it really illustrates the fact that you can have multiple ecological communities in the same place at the same time. They're called biomes. South of Cuba are the Grand Cayman Islands. There are 4 distinct biomes living at the same time and the same place. From 0 to 200 feet, the area called the reef, there are thousands of typical shallow water species like coral, barracudas, stingrays, eels, and so forth. And then going down from about 200 to 600 feet, you come to the wall, which is also known as the sponge belt. It has lots of various types of sponges, worms and crustaceans, and there's not that much overlap between the reef and the wall. Moving down more, 600 to 1,000 feet, we have an area called the haystacks. There's lots of debris broken off from above, and it also contains sharks, starfish, sea whip corals, sea urchins, and so forth. And 1,000 feet and under the deep, which is totally dark, you have things like the cookie cutter shark, the coffin fish, tripods fish, spidery armed jellyfish, sea cucumbers, and so forth. And there's not very much overlap in between the 4 different ecological communities, and they're found at the same place and the same time. So if we could instantly freeze it and then start to dig it up in thousands of years, we might look at it and say, wow, that looks very much like a suite of fossils. It's very much like what we see in the fossil record. So, which suites of fossils contain dinosaurs? We use the suite of fossils, a characteristic group of fossils, to identify strata. Sometimes the strata are identified into lower, upper, and perhaps the middle. Okay, so the lowest layer containing dinosaurs is the upper Triassic. There are also distinct dinosaur suites, lower, middle, and upper Jurassic, but the majority of the dinosaur types occur in lower and upper Cretaceous. There's occasional overlapping where a type occurs in more than one layer. For instance, if you look at the world today, you're going to find rats everywhere, you're going to find cockroaches everywhere. Well, in the fossil record, there are a few different types of dinosaurs that were able to survive in more than one ecological community. And the community is going to be defined by its amount of rainfall, its elevation above or below sea level, the amount of plant life, and what type, and so forth. But the dinosaurs appear to have lived in 6 different ecological communities. How much evolution is there? None. All of these ecological communities and the individual types within them appear fully formed with nothing leading up to them, nothing leading to the next one. If there are some fossils that are appearing in 2 or more different ecological communities, they don't evolve. The ones at the bottom are easily identifiable as the same type as the ones at the top. So why is there uncertainty in how many extinct types there are? Well, what's a species? This is a man-made designation. The Bible talks about a kind. It doesn't define that for us. And likewise, we do have a definition that may not fit with what the Bible talks about. To a biologist, species and genera are groups whose members cannot breed with any other group. So, do an experiment and show me whether these 2 fossils are the same species. You can't. You can't do breeding experiments on dead animals. So researchers have to simply guess whether they belong to different species, different genera, based on how different the specimens seem to be. So looking in the world today, if you had only bones to go by, if you've ever seen The Princess Bride, you've seen one of my favorite actors, Andre the Giant, and then also Vern Troyer, who's been in some Austin Powers movies. Andre the Giant is 7 feet 4. Vern Troyer is 2 feet 8. They don't look like the same species, do they? But they're both Homo sapiens. Unless you saw them together, if they were instantly fossilized and you dug them up in 1,000 years, you might think they don't even belong to the same genus, might be different genera. No, they're both Homo sapiens. So there's no way to be sure whether the differences in extinct creatures mean they belong to different species or just showed normal variation within the same species. Andre the Giant, Vern Troyer, they are the same species, Homo sapiens, even though there's a lot of difference between the 2. So likewise, we've got a lot of variation among the dinosaurs. How many types of dinosaurs were there? The actual number of dinosaur types is probably significantly less than the number of names assigned. Some estimate that at least 1/3 of the names are duplicates, and almost half the names have some sort of error. You'll find that in National Geographic News in 2009 and in Nature online. Whoever discovers the first fossil of an extinct creature gets to name it. However, the discoveries are often fragmentary, perhaps a few teeth, some pieces of bone, and so forth. And this is a surprising thing. As of 1990, 45.3% of all dinosaur genera were based on a single specimen. It may even be a small fragment of something. And as of that time, 74% of the names of dinosaur groups were based on 5 specimens or less. There's been a number of times where someone named what they thought was a new type, only to find later that it had already been named. Some of the duplicate names are still around. For instance, some believe, paleontologists, that Tyrannosaurus, Tarbosaurus, and Albertosaurus are the same creature, and perhaps even that Nanotyrannus was just a juvenile Tyrannosaurus. We don't have a way to test it, so we need to be very careful in making dogmatic statements about how many types there were. So there are some major differences between living reptiles and dinosaurs that may have to do with the multiple names being assigned. They're modern baby reptiles. When they hatch, they come out as miniature versions of adults. They can immediately eat what adults do. Mammals do not. You don't give your new child a steak. You give them milk, and they gradually develop the ability to process it. Well, likewise, mammals, the rest of the mammals, have to start out with milk, and then they'll gradually be able to eat the solid food like the adults can. Dinosaurs were different. They seem to have undergone radical changes as they grew, somewhat like mammals, but their diet probably was not different. For instance, some types of dinosaurs, like the Zuniceratops that you'll see there, had no head frill as babies and grew them later. So if you saw the adult and you saw the juvenile, you wouldn't know that they're both the same species. Also, dinosaurs and the pelycosaurs, which are called mammal-like reptiles, they had legs directly underneath the body. This meant if they lived long enough, they could grow to enormous size, and they might be mistaken and misidentified as separate species. So if you look at something that has its legs splayed out to the side, like alligators and so forth, they're limited in how big they can get. Now, they're in the water, so that supports their weight a lot of times. But if it's a land animal and the legs are directly under, the legs can support the weight much better than if the legs are off to the side. So in some cases, such as Nanotyrannosaurus and Tyrannosaurus, I know this is disputed, normal changes due to aging may have resulted in multiple names being assigned by mistake. So how many types of dinosaurs were there? The lowest layer that contains dinosaurs is the Upper Triassic. There are somewhere between 16 and 50 genera have been named. We can't do breeding experiments, so we can't be sure there really were 50 distinct types, rather than variation within a smaller number of types. The dinosaurs found in the lowest layer, the Herrerasaurus and the Guayabosaurus, are both considered to be in the Upper Triassic. So what evolved into them? Nothing. There's no transitional form leading to them. And then once they appear in the fossil record in the Upper Triassic, what's the transition leading from there to the Lower Jurassic? There is none. They appear, all of them, suddenly and fully formed with nothing leading up to them. So where are dinosaurs on the geologic timescale? They're all in the Mesozoic era, the Upper Triassic period, and then the Lower, Middle, and Upper Jurassic, and the Lower and Upper Cretaceous. So they're in 6 distinct communities in the fossil record. So if you think back, the lowest levels, the Devonian, Silurian, Ordovician, Cambrian, those are ocean bottom type creatures, or at least oceanic creatures. When you get up to the Devonian, they're more shallow water types. The Permian, the Pennsylvanian, the Mississippian, which are the Carboniferous, they tend to be the kind of things you would find pretty close to sea level, maybe swampy type things. And then the dinosaurs are in the age of reptiles, which is considered the Mesozoic era. There's some of the types that are found in the Triassic. These are not dinosaurs. Hypasuchus, it's an ichthyosaur, which looks a lot like a fish. Postosuchus, which is a crocodile-like Upper Triassic reptile. Turfanosuchus, it's considered to be a stem reptile. And then Placereus is from the Upper Triassic. It's supposed to be mammal-like. Now, mammals are supposed to have evolved after reptiles and so should be more advanced. The problem is that the more advanced mammal-like reptiles are actually found in lower strata, lower layer than any of the dinosaurs. And of course, they still all appear suddenly and fully formed with nothing leading up to them. So if you consider the mammal-like reptiles, so-called mammal-like reptiles, the pelycosaurs, and compare them to dinosaurs, the mammal-like reptiles disappear from the fossil record before the dinosaurs come along, even though mammal-like is supposed to be more advanced. And then the marine and flying reptiles are found in the same strata as the dinosaurs. Birds first appear early in the fossil record with dinosaurs, and then they continue to the present. Mammals actually first appear along with the dinosaurs also. Not that many mammals back then. When I say back then, I mean according to the standard time scale. So these are some of the dinosaurs you're going to find in the lower Jurassic. There are about 220 types that have been named Jurassic dinosaurs. Some in the lower, some in the middle, some in the upper Jurassic. That's an average of about 70 types per biome. Is that unreasonable? No, there's a lot of stuff in the world today where you have a bunch of different things in the same biome. But the actual number could have been considerably less because of duplicate names. You also had some non-dinosaurs that are found in Jurassic rocks, which are supposedly at the same time. But for instance, the plesiosaurs, Macroplatia, and Stenopterygius and Ichthyosaur, and the pterosaurs, Campylognathostis, I hope I said it right. Those are also found in rocks dated to the Jurassic, but they don't evolve. Here's some of the middle Jurassic dinosaurs: Szechuanosaurus from China, Cetiosauriscus, Yangchuanosaurus, Belosaurus, Monolophosaurus, Spinophorosaurus. If you want to do some tongue twisters, guys, try saying those 10 times in a row fast. But there were dinosaurs, and there are also non-dinosaurs. Bichonopleosaurus, Neptunidraco. Okay, so these are dated in specific time periods, supposedly time periods. I would say that they are found in a particular community of fossils. The upper Jurassic dinosaurs are some of the familiar ones. The Stegosaurus, of course, everybody's familiar with. And then Camarasaurus. There's a great Saints football player, Alvin Kamara, but he's not related to the Camarasauruses. Then the smallest known dinosaur was Compsognathus, and Camptosaurus and Diplodocus was one of the big guys. Othnielia, named after Othniel Marsh, a famous paleontologist. Those were not much bigger than the Compsognathus. And then some things that were not dinosaurs, the Archaeopteryx, which is the fossil bird you've probably heard a whole lot about. We'll talk next time about whether birds evolved from reptiles. And Rhamphorhynchus, which is another one of the pterosaurs. It's not considered to be a bird or an ancestor of a bird or anything like that. Now, here's a surprise for you. If you watch Jurassic Park, you remember the Tyrannosaurus Rex, T-Rex? They should have called it Cretaceous Park because T-Rex was found in the Cretaceous layer, not the Jurassic. Here's some other things in the lower Cretaceous. There are over 500 types of dinosaurs that have been named in lower and upper Cretaceous rocks. So if we take into account the possibility there could have been duplicate names, each of the fossil communities in the Cretaceous, lower, middle, and upper, lower and upper, not middle, each of them may have averaged 100 or more types of dinosaurs. Sinosauropteryx, Zingosaurus, you try to pronounce these, Microraptor, Deinonychus, Confuciusornis. Who's that named after? Confucius. Scipionyx. So in the Cretaceous, there were a lot of dinosaurs, a lot of individual names, but they don't evolve one to another. They all appear suddenly and fully formed with nothing leading up to them or from them. These are some of the dinosaurs found in the Upper Cretaceous. The T-Rex, as I said, they should have called it Cretaceous Park. The Daspletosaurus in the Field Museum in Chicago. Velociraptor, it was not nearly as big as what you saw in Jurassic Park. They wanted to make it more dramatic, so make them bigger than a human. Well, the largest specimens we found have not been near human size. Centaurosaurus, Majungathalos, Oviraptor, Protoceratops, Ichthyornis. Ichthyornis was a bird. Pteranodon was one of the pterodactyl types. And then Elasmosaurus was not a dinosaur at all. It was one of the plesiosaurs. So because of duplication and uncertainty, the number of types of dinosaurs is probably much less than 1,000. The U.S. Geological Survey estimates that there may be as few as 300 valid genera. So there's so much variation within a type, and you can't tell just by looking at something and seeing it's similar to that. Could they have bred together? You can't tell. So even if there were many more types of dinosaurs, that wouldn't prove anything about evolution. Birds give us a good basis for comparison. There are over 2,800 genera of birds living in the world today. So when we divide them into species, there are more than 10,000 species of birds. That's a lot of different types. Okay, so what's evolving into what? The large number of types of birds does not indicate that they're evolving. Likewise, a fairly large number of types of dinosaurs, nowhere near the number of birds, it has nothing to do with evolution. The first type of dinosaur and the first type of bird that appears in a fossil record is suddenly and fully formed with nothing leading up to it and nothing leading from it to something else. So in the next episode, we'll deal more with the idea that perhaps dinosaurs evolved into birds, and we're going to see some of the problems, some of the biological and paleontological problems with that. So I hope you're getting something out of this.